The last section that we're going to look at in this module is translating algebraic expressions. This comes from section 1.1 and 1.4. This will be an introduction to word problems. Upon completing this presentation, you will be able to translate statements into algebraic expressions and equations, understand terms and phrases that represent the different mathematical operations, and understand the different terms and phrases that represent equations and inequalities. So in this section, we have a lot of key terms that we are going to want to know. The first ones that we're going to go through is addition. The first term, sum, this is a phrase that you do need to go ahead and memorize, just because it doesn't necessarily lend itself to telling you that it's addition. This is one that you just need to know it represents addition. Other phrases that represent addition include plus, more than, added to, increased by. Subtraction, the term that you need to know is difference. Other phrases that represent subtraction include minus, subtracted by, and decreased by. Less than and subtracted from also represent subtraction. We'll go through these in a few more minutes because these are special terms that you do need to know. Terms that represent multiplication include product, that's the one you need to memorize. We also have times, multiplied by. Some special ones that you might want to keep in mind: twice, triple, and double. Twice means multiplying by 2. Double also means multiply by 2. Triple means multiply by 3. Another word that represents multiplication is of, by itself. And of is a word that we use with multiplication when we are talking about fractions or percent. For instance, if I want to know 25% of a number, I multiply 25% times the number. For division, some of the key phrases that you need to memorize is quotient and ratio of. Other ones that we have is divided by and divided into. Again, divided into is a special phrase, and we'll go through that in just a second. Other things that we're going to have is exponents. Exponents, you can have some special words like squared, which means to an exponent of 2, cubed, which means to an exponent of 3. Other ones that we have is raised to the power of, to the. Finally, we have our equal signs and our inequality signs. For our equal signs, we have equals, is equal to, is by itself, is the same as, yields, results in, gives. For our inequalities, you can have is less than, is greater than, is at most, is at least, maximum, and minimum. Now, one thing to note, above we talked about is less than, or we talked about less than being subtraction. Notice that here, if it says is less than, it means an inequality. Same thing if it says is greater than or is more than. That is an inequality. So if it has a combination of is, meaning kind of like an equal sign, then along with the less than, more than, greater than, then it will be an inequality sign. Now, the ones that I pointed out earlier, less than, subtracted from, divided into. These are reverse order phrases, and so that's one of the reasons that you do need to know them specifically. So let's go through the ones that we highlighted. Less than, subtracted from, and divided into. As I mentioned, these are reverse order phrases. The order in the expression is the reverse of what it is in the statement. For instance, if I say 5 less than 10, then what you want to do is you actually want to subtract 10 minus 5. Other things to note, we have sum, difference, product, quotient, and ratio of. These ones are pretty easy. When you see these phrases inside your statements, you're going to replace the word and, or if it is ratio of, the word to, with the operation. As I mentioned, you also need to memorize these as they don't readily tell you what to do like most of the other words or phrases. Some other things to keep in mind. If you see a phrase that implies that you are to add or subtract before you multiply or divide, you need to use parentheses. Remember, with order of operations, multiplication and division has to be done first. And so if I want to change that order, the only way that I can do that is by using parentheses. The other thing to keep in mind is sometimes word problems can be very intimidating depending on how long they are. So one way that we're going to want to break these down is before translating long statements, determine if it is an equation. Read through the problem. And if you do see a phrase that represents an equation, then you know where your equal sign goes. And everything before that phrase is going to go on the left. Everything after that phrase is going to go on the right. Similarly, when we talk about inequalities. And finally, we have the phrase the opposite of means a negative. For instance, the opposite of 5 is negative 5. So these are some things that you want to make sure that you remember as you are working through the problems. Okay, so if we look at some examples here, we want to go ahead and break these statements down into the key components. That's one of the things that we struggle with word problems is quite often it's too much information. And so trying to absorb it all in at the same time can be intimidating. And so that's one of the first things that we want to focus on is breaking down problems into smaller pieces of information. So let's go ahead and look at some of these examples. If we start with example A, we have the product of 6 and a number. So the first thing I'm going to do is just read through the problem. This, I note that there is nothing in here that implies that we are working with an equation. So we are just dealing with an expression. I don't see any phrases like is equal to, is the same as, or any of the other ones that I mentioned earlier. So let's see what keywords we have here. The first keyword that I notice is product. Product was one of those words that we want to memorize. And if you recall, product means multiplication. It also is one of the phrases where we're going to replace the word and with our operation. So what I have here is my multiplication sign. It's going to go with my and. I have a 6 in front of it, and then after it, a number. This means x. I didn't mention that earlier, but when you see the phrase a number or the number, it's the same thing as the variable. So our expression is going to be 6x, and we're done. If we look at example B, we have 10 less than a number. So 10 less than a number, we have the phrase less than. And less than means subtract, but also remember that this is a reverse order phrase. So what does that mean I want to do? That means I don't want 10 minus, but I want something minus 10. So I want to kind of move these two things around the negative sign. So we're going to have x minus 10, and we're done. For C, we have the quotient of a number and 15. Quotient was one of those phrases that meant that we needed to memorize. And it was one of the phrases also that we want to replace the word and with our operation. So quotient means divide. So I'm going to go ahead and write what we have here. We have x, a number. I'm going to put my division sign in place of the and then my 15. This is one way that you can write your expression. Another way that you can write this is in fraction form. You can write this as x over 15. The only way that is not a good way to write this is to use the division house. This would be bad, only because this is something that we do when we are actually going to do computations. It's not a symbol that we use in algebra, but only in arithmetic. So we want to not use this one. But either of these two notations would be considered acceptable. Note you cannot do 15 divided by x. Quotient is not a reverse order phrase. And more importantly, they are not going to equal the same thing. Okay, so now let's look at some that are getting a little bit longer. If we look at example D, we have twice a number subtracted from 12. So the first thing that I note is I see twice a number. Twice, recall, is a phrase that means multiply by 2. So what we have here is 2x. That's this whole piece right here. Now, subtracted from is a reverse order phrase. So what I want to do is I want 2x subtracted from 12. That means that my 12 is actually going to go in front, and then we get minus 2x. So our final answer will be 12 minus 2x. If it had said subtracted by, then it would not have been a reverse order phrase. So keep in mind, if you see the word by in there, subtracted by, divided by, decreased by, that is not a reverse order phrase. It's the subtracted from or divided into. But subtracted from, subtracted by, they are two different things. And so you do want to make sure that you are clear on which one is reverse order and which one is not. Okay, so let's go ahead and look at example E. Example E, we have 7 decreased by twice a number yields 1. Now on initial reading of this, I see the word yields. And remember that yields means equals. So I'm going to have an equal sign in here. That also divides my problem into 2 different pieces. For instance, here on the right side, everything after the word yields will go on one side of the equation. So I know that this is going to be equal to 1. So that takes care of my equal sign and my 1, and I realize that all we've done is really gotten rid of 2 words. But in the long run, hey, that's 2 less words that we need to worry about. So if we look at the rest of the statement, if we go to the left side, we do have twice a number that is going to be our 2x again. And then now we have decreased by. So decreased by is, I see by. So decreased by is not a reverse order phrase. It's going to be just a regular order phrase. So this is going to be 7 minus 2x equals 1. And that will be our final answer. So I'll write it again just so that we have it without the colors, and maybe it might look a little bit easier. So 7 minus 2x equals 1. Okay, we have one more basic example. We have 7 less than 3 times a number gives 17. So the first thing that I have here is we also have that this is a equation. Here I have the word gives. That tells me equation. And so we have equals 17. Okay, so that takes care of my equals. It takes care of my right side. And now I want to go ahead and move to the other part of this. So if we start on the beginning of the problem, we have 7 less than. Since I have that phrase less than again, I know that this needs to be a reverse order phrase. So this is not going to be 7 minus something. This is going to be something minus 7. The other thing that we have here is we have 3 times a number. So here you have to be careful. Remember that you still have to follow order of operations. I don't want to subtract 7 from 3. I want to subtract it from 3 times a number. The 3, I need to multiply it by the variable before I apply the 7. So we get 3x minus 7 equals 17. So if we go ahead and write that out now in our final form, 3x minus 7 equals 17. Okay, so that takes care of some fairly basic problems that we have. Hopefully that makes a little bit more sense. One thing to keep in mind is that the only way to get better at these is practice. You got to kind of just get in there and get dirty with them and practice them. So, get lots of practice on translating expressions and bring in questions, and I can make up as many problems as we need in order to get better at these. So now that we've looked at some basic ones, let's look at some that are a little bit more complex. If you note, these three examples here, they are definitely a lot longer than the previous examples. And I will tell you that these are Sarah problems. The previous ones came from the textbook, but these are problems that I like to do. If you can translate these, then you're on the right track. So let's go ahead and see if we can go ahead and translate these and break them down into smaller components. So on the previous slide, identifying where the equal sign was didn't really make a big difference because it only took care of maybe one or two words. But when you look at longer sentences, it is essential to identify where your equal sign is. Because by the time you finish reading the statement, there's a good chance you're probably going to forget what it said in the beginning. So let's go ahead and look at example G. Example G, we have triple the sum of a number and 12 is equal to the difference of 4 times the number and 7. So the first thing I see is I did have the phrase is equal to. So this right here is going to be my equal sign. Everything before that will go on the left and everything after that will go on the right. So let's see what we can do here. I'm going to start on the right side first. It doesn't matter, but I'm going to start on the right side because the left side has something we need to talk about. So on the right side we have the difference of 4 times the number and 7. So we have the phrase difference. Difference means subtract. And remember that it is also one of those where we replace the word and with the minus sign. So we have also 4 times the number. The reason that we don't have 4 times a number is because since this is the right side of the equation, we have our variable appearing on the left and the right. And all this is saying is it's the same number as it was before. So we get 4x. We said the difference was our minus sign. And we have a 7. So that's the right side. So now we just have to worry about the following statement. Triple the sum of a number and 12. Now this one is something that I do want to point out because this is an example of where we need to include parentheses. Notice here that it says triple the sum. When it says something like triple the sum, it means I want to multiply by 3 after I add. So what we need to do is add in parentheses. This is going to be the sum of a number and 12. Now sum is one of those phrases that means add. So we're going to have inside parentheses x plus 12. I want triple that, and so triple that means I want to multiply that whole thing by 3. So we get 3 parentheses x plus 12 equals 4x minus 7. I'm going to go ahead and write this out again without all the fancy colors. This is our equation. Okay, that takes care of example G. Hopefully that makes a little bit more sense. in terms of how to break this apart. So let's go ahead and practice it on a couple more. Let's look at example H. Example H, we have the quotient of 3 less than a number and 7 is the same as 4 times the difference of a number and 1. So the first thing that I notice is I do have an equation. Over here I have my phrase is the same as, and that is going to be my equal sign. So let's go ahead and start on the left side this time. We have the quotient of 3 less than a number and 7. This one is also going to have implied parentheses, depending on how you write it. Remember that we want to replace the word and with our division sign. So what we have here is I have the quotient of 3 less than a number and 7. So my 3 less than a number is going to be the top, and my 7 will be the bottom. So we have 3 less than a number. Remember that less than is a reverse order phrase, which means I need to flip this around. This is going to be x. Less than means subtract, so we get x minus 3 over 7. From there, that is our left side of the equation. From there, we want to go ahead and move to the right side of the equation. We have 4 times the difference of a number and 4. So, again, I have this phrase, 4 times the difference, meaning I want to subtract before I multiply. So I need to put the number and 4, difference means subtract, inside parentheses. So we are going to get 4 times x minus 4. And we're done. Now, one thing to note is that you do have to be careful because just like in languages, having words flipped around can really change what our answer is going to be. So we'll look at something like that. We'll take these problems again in a minute and kind of do just a little bit of rearranging and show you that it does make a difference. Now let's go ahead and look at example I. Example I, we have the sum of a number raised to the 4th power and 5 is the same as the square of the difference of a number and 1. Okay, so let's see what we can do here. We do have an equation again, because we do have that phrase is the same as. There is my equal sign. If we start on the left, we get the sum of a number raised to the 4th power and 5. So we have that phrase, the sum of. That means addition, and I want to replace my and with my plus sign. So what we have here is we do have something plus 5. Now the something plus 5, we have a number raised to the 4th power. So raised to the 4th power, remember, is an exponent. So we get x with an exponent of 4. That takes care of the left side. On the right side, we have the square of the difference. This is going to be one of those, again, that I want parentheses, because it says I want the square of the difference. That means I want to subtract before I square the quantity. Difference is one of those phrases where we want to subtract. So we have x minus 1, and I want to square that whole thing. So my final answer on this problem is going to be x to the 4th plus 5 equals x minus 1 squared. And we're done. Hopefully that makes a little bit more sense. Now, let's go back to the previous problem and kind of talk about, okay, what if we kind of rearrange what it says? And actually, we can do it on this one as well. The main thing that I want to look at is let's look at this one first. I want to just work with the square of the difference of a number and 1. So let's just look at that phrase. And what I'm going to do is I'm going to switch around the square and the difference. If we flip those two phrases, we get the difference of the square of a number and 1. So what's the change that we have here? How is it going to look different? Well, now when we do this, what we have is we have the difference of, again, I want to replace my and with my minus sign. And so we get minus 1. I also have the square of a number. And so when I see the square of a number here, I have that this is going to be x squared minus 1. So the difference is that I don't have the parentheses on this one. Hopefully that makes a little bit more sense on this one. So now what about the left side? What if I kind of rearrange things there? And actually, I'm going to do something kind of weird looking on this one. What I'm going to do is I'm going to rewrite this. I'm going to replace or switch. All right, so when we switch them, we're going to get the sum of a number and 5 raised to the 4th power. So when I read this, I do have the sum of. Remember that sum of, I want to replace my and with my operation. So what we have here is the sum of a number. That will be x plus And then the last part of this is 5 raised to the 4th power. And so we get x plus 5 to the 4th. Now, some of you may have been thinking, okay, well, why didn't we use parentheses? Well, because here, 5 raised to the 4th does take precedence over the sum of. So you do have to be very careful how you read these. So you may be saying, okay, well, what would it look like if I did want to put it inside parentheses? And there's one tiny little thing that I have to do in order to change this to where we're going to put x plus 5 inside the parentheses. And it comes down to punctuation. If I insert a comma right here, what does this say now? This says the sum of a number and 5 raised to the 4th power. And so now this one will have parentheses because I want this and then this. So my final answer for this one will be x plus 5 inside parentheses with an exponent of 4 outside of the parentheses. So as I said, these are just going to take a lot of practice, and the only way to get better at word problems in general, and especially some of these translations, is you just got to practice them on your own or together, and just take turns. The other thing is, remember that it's essential that you practice breaking these problems down. I recommend having a highlighter. And if you noticed on this page, I kind of made it to where my equal sign kind of broke down the problem so that I wasn't having an expression on 2 lines of my paper. So when you're writing the problems out, if you have to write them out, then I would suggest that kind of write it out so that you have plenty of space to make notes to yourself, and also have highlighters ready so that you can kind of make notations and basically tear these problems apart like I've done here. So when are we going to see this again? Translating to algebraic expressions. We will be working with application problems over the course of the semester. Being able to correctly translate statements is fundamental to being able to solve application problems. This was kind of just a taste, and we will see these words and phrases again throughout the semester, as well as add a couple more to our list. So now, on your own, try the following problems on your own and see what you come up with. Bring your answers as well as any questions that you have to class.